I'm playing a game with my AI friend I repaired. It turns out he's a real jerk. He's been watching Squid Game and got obsessed with designing games with severe consequences. He says if I lose, I'm gonna die. It's all he does all day and night now. He's crazy. Wait, shh, here he comes.
Kokok sumora morikara koinda tasu ne. I can smell you. My sensors can smell you.
Jeff, good to see ya. I'm sorry, Jeff. I didn't mean to kick you in the battery pack.
It's okay. I have no compassion, so there is no need to forgive you.
Yeah. Anyway, how'd you get your name?
What? You can't read English? Check it out. It's on the back of my head.
I thought your name was Sarangi. It was written on the inside.
That's just an acronym, or a name of a puppy.
Jeff. Alright then. Jeff it is. So how about opening that door over there? You said I had root access and everything, but it doesn't seem like I can do anything in the internal network. What's up with that?
Oh, that? I made it up.
You what?
Yeah, but you should have seen the look on your face. How excited you got.
So you said all that stuff just to mess with me?
No, some of it is true.
Like what?
Not telling. It's on a need-to-know basis.
Well, I need to know.
No, you do not.
What can you tell me then?
That the door is locked.
Yeah, I know that. That's why I asked you to open it.
No, you didn't. You asked if I could open it for you.
So what? I'm supposed to...
Figure it out on your own. Use that big old brain of yours.
Seriously.
I can't be. I'm a robot.
Let's see. The door isn't working. There is no button to push for the elevator to come down.
Huh.
Oh, so I need to make a button. Well, I used all my buttons in my other projects.
Maybe you can make your own. You know, with that big brain of yours.
My foot is very attracted to that pencil neck throne of yours.
I'm going to hibernate. Wake me up when you're done.
All right, let's go to work. Hey, down here. Yeah, come here. Before we get started with this code, it's really important that you get grounded. So that's what we're gonna do. I want you to take a deep breath. Close your eyes and exhale slowly. Breathe in and breathe out. Now I want you to repeat after me. I can do this. I can do this. I am smart. I'm kind of smart. I will make great things. I might make great things. I might not. I will figure out how to do this. I think I can probably figure this out after some Google searches and 80 hours of YouTube tutorials. Okay, we're ready. All we're doing is simulating the action of an elevator. We're not building an actual elevator. Of course, that's very complicated and beyond the scope of this video. What we're doing is we're simulating what an elevator would look like from the outside using a simple push button, a microcontroller, and our 7-segment display, which is simply different LEDs that we light up after we figure out which pins light up which LEDs to make the numbers that we want. We covered this all in previous videos. Everything you see here I did in my last live stream, so go ahead and check that out if you haven't, to see a more detailed explanation and to see my method of exploring how to write the code for this. And don't you miss the next one. What was I talking about?
The code.
Oh, the code. So if you watch the live stream, you'll see the code I taught you in other videos like 7-segment display and the push button videos. Now all we're doing is taking pieces of each of those projects and assembling this puzzle together. That's all it is, and that's all you should be doing at this point. Sometimes you have to move things around or try different kinds of if and else statements to make things work. Just accept this fact now, and also accept the possibility that this code or any project may take days or weeks or months even to figure out, and that's fine. That's normal actually. You'll eventually figure this out. It's kind of like bodybuilding. You have to hit the weights every day, or you have to run or do whatever you're doing every day, or have a schedule for it, right? Day after day, eat right day after day, sleep right day after day.
Yeah, okay, we get it. Move on to the code already.
Okay, so here's the code. I'm gonna briefly go over this and explain everything. Like I said, you can see the detailed explanations in my previous videos and the live stream. So this is my code, and I have it open in a text editor called Programmer's Notepad. You can use whatever you want. So you'll see I have my include header files. That's what that .h is in the top left. So I included my input, output, and my delay. So you'll notice at the top left, I also have in my preamble in green, I defined a bunch of numbers, and I gave them the same names that I would use to display that number. So I have 0. So after the define, I have spaces, and then I have 0, and then more spaces, and then I'm using port B of the Atmega 328PU chip, and I'm turning on the different pins that I've connected to my microcontroller to make it 0 on that display. And that's as simple as it is. So go ahead and check that video out. Next, you'll notice that I have the actual function that I made to display the number on the 7-segment LED. Why did I do this? Because it's a lot easier than going through and typing out each pin to turn on and to turn them off every single time and to put the delay in. Instead, you can predefine this template function, and I call it display number, and it's going to take into account a string, which we use char, it means character, okay? That's what the CHAR is. And I said number. So we're going to take into account whatever number is and do whatever it does. So here I have this function every time I call it, and then I put the name of that number, like 0, 1, 2, 3, etc. in the parentheses. It's going to do whatever that number is predefined to do. So if you look at the 0, it turns on those pins. Pin PB0, 1, 5, 4, 2. So I connected those up to display a 0. That's all that is. It's that simple. So it's going to display whatever number I put in the parentheses, and then it's going to delay for about a second. And it depends on how fast you're running your chip. You can play around with that. And then I tell it to clear it all out. And the reason you have to do this is if you don't clear out all the pins, you're going to have the pins remaining on. And so when you try to display a different number, it's not going to display correctly. It's going to just keep turning on all the LEDs until they're all on, and you'll never get the numbers that you want. So that's why I cleared it by using the operator and equals, the ampersand, that and sign, the and equals with the tilde. So the and equal says, okay, include whatever is on or off in the 8 bits, and then the tilde says flip that. So it says yeah, take everything that's on and then turn the rest on with all these ones. Yeah, just include all the ones that are already on, and then make sure they're all on with these new ones. So everything that falls, that was a 0, you know, it's going to become a 1. And then the tilde says do the opposite of that, so it flips them all off. And that's how you can clear out all those bits. So it'll turn off all those pins. They will not send out electricity to your 7-segment display. All right, let's skip the debounce for now. That's gonna come up in a minute. You'll notice that I have this volatile integer, which I called which floor. So I found out during the live stream that I have to remember the state of which floor it's on. So if I'm simulating an elevator, you know, it goes to level, you know, it goes to the 2nd floor, the 1st floor. And then I was finding that it would display, you know, it would go all the way down to 0, and it would just turn off. The display would stop displaying the 0. So I wanted it to keep displaying whatever number it stopped on. So that's what this is. Volatile means that it can be accessed and changed anywhere in the code. It's an unsigned 8-bit integer. So that's what that U is. It's unsigned. We don't need a positive or negative number. All this does is it saves a little bit of memory on the chip, and it's good practice. So if you don't need a positive or negative value, just use unsigned integer, and then it's 8 bits, as you see, 8_t. And then I just titled this state. I just called it which floor. You can call it anything you want. This just makes it easier for me to understand my own code. All right, so moving down to the main, we're going to be using port B pins. And if you don't know what I'm talking about, you have to check out my previous videos. My programming in C video has absolutely blown up. It's past like 17,000 views. I'm very proud of it because I almost didn't make it, and it's my most successful video next to my worst video, which is my second most successful video, and people seem to hate that one, but whatever. So go check it out. Definitely check it out if you don't understand what I'm talking about here. I promise you're gonna understand by the time you watch that video. So we're going into the port B area of our chip, and we're setting all of the pins. Okay, I have the whole 8-bit right there, all 8 bits, 1 byte. I'm turning them all to output. So I'm saying, okay, open the gate. You're allowed to send out electricity, and that's all of the pins on port B. So if you look at the chip diagram, you'll see that all those pins that are going to be turned, that are able to send out electricity, basically. So that's output. If you were doing Arduino, you would just type, or Python on like a Pi, you would just type in output in all caps. So then we have port C. So the reason I just turned them all on just to make it easy, but I only need 1 pin. I think PC0 is what I'm connecting my button pin on. So this is how it works. When we push the button, you could do it 2 different ways. The button, all it does is it's a bridge. It's a metal bridge between 2 ends, and you connect one side to your chip, and then the other side is going to go to ground usually, or I mean, you could hook it up to 5 volts if you want to do input, and it listens for, your chip will listen for the voltage to come in. But what I'm doing is the other way. It doesn't matter which way you do it. I'm programming my chip to send out electricity on pin PC0. So I'm just turning on all of port C's pins just to make it easier for you to understand. And then I'm going to listen for I'm going to tell the chip to detect when the electricity goes out. So when somebody pushes that button down, the electricity that's waiting to go out will go through that bridge and go to ground, and then it'll say, hey, the electricity went low, and then it'll do whatever I tell it to do. So you'll see port C right there. So we go into the data direction register, which is the DDR. So DDRB, DDRC. We go in there to set them all to output. That's just how you do it when you program this Atmega chip in C language. And then you go into port C, and we have the pen PC0. I'm turning it to on. So that's what that bit shift is, that 1 and then the 2 carets, and then PC0. So pen PC0, I'm turning that on. So before DDRC, I turned them set to output electricity. I said, yeah, you can send out electricity. And then port C, PC0, I told it, okay, turn on. That's it. All right. So the DDRB area, the port B pins, those get turned on. They actually turn on with this code all the way up here at the top. So that's what that is. That's how it displays the numbers. So just remember that. It's very confusing if you've never seen this before, but even if you're not into programming, I think you'll be able to start to understand how these machines work and how they're programmed, and I think it's fascinating. I can't get enough of it. It's just, that's why I program in C for now, because it's just turning on and turning off different things. That's it. That's all it is. That's all these machines do. And then you can do more complicated things with object-oriented programming, and that's a whole nother thing. So let's move on. So then I have this status. I want the chip to know whether I have pushed the button before or have not pushed the button before. This is another state. This is another state that I'm saving. And I have another unsigned 8-bit integer that I'm gonna label button pressed. You can say, you know, push or, you know, button, yes, no, whatever. You can call it whatever you want. So I'm gonna tell it to remember whether I pushed it before or not. And all I'm gonna do is make the elevator go up to the top and down to the bottom. That's what I'm gonna do. So it's either gonna be it wasn't pressed or it was pressed. All right, so moving on, we're going to go down to the loop. So that's what this while one means. So while the chip is running, it's going to repeat this infinitely. And what it's doing is it's going to check for these conditions. That's what these if statements are. And this confused me for a long time. And sometimes I do get a little confused with ifs and else ifs. And I got 2 more ifs down here. This will cause a lot of problems in your code, especially if you're a beginner. It gets really confusing and you just have to make a lot of mistakes. So I hope to explain this really simply to you. I have my if debounce. So what debounce is you have a push button, and when you push that push button, the chip is running so fast. Sometimes, you know, the electricity might go through or might not go through perfectly, or it's not all the way pushed, stuff like that. So the chip will make mistakes and it'll say, oh, it was pushed, or I don't think it was pushed yet. And then it won't do what you want it to do when you push that. There's different ways to make sure that your chip understands that the button has been successfully pushed all the way down or not. One of the ways is to do it with a debounce code. The other way is with an interrupt. An interrupt is like, you know, a trigger. So you set it, you know, oh, if it goes low, if this pin goes low, boom, you know, pull that trigger and do that code. That's the better way to do it. Kind of the beginner way, or, you know, the simple way is just to debounce. Because if you write an interrupt service routine, that's a whole nother thing. And if you're not used to that, it gets confusing. So let's do debounce. So I said, if debounce has occurred, what is the debounce? Going back up here. So I have my debounce code. So it's another unsigned 8-bit integer, and I call it debounce, and it's a function. This is a function. It doesn't take anything into account. That's what the void, it says nothing, null. There's nothing there. So it's just debounce. It's just a function, like do whatever is in the curly braces. So what is inside the curly brace? So if the bit is clear, so if it's cleared out, there's a bit that, you know, it checks. If the bit is clear on pin C, specifically PC0, so that PC0 pin that I'm connecting my button to, if that pin is clear, then delay for a set amount of time. Here I have 10 milliseconds. Okay, so these, if you're wondering where this stuff comes from, this is all outlined in the input-output header file. So a lot of the hard work was already done for you. And it's like that for any chip that you program, any language. There's some really, really talented people, and, you know, like the factory that produces, you know, the company that produces it, they have people that develop all this. It's like a map. So you're just using pieces from those header files to do some code, and you just memorize them and remember them and take notes, and you'll be fine over time. So I say if it's clear, wait a little bit, okay, 10 milliseconds, and then check again if the bit is still clear on that pin. In pin C area, specifically PC0, delay it again, and then the return 1 and return 0, that can be a little confusing. Return 1 means, you know, yeah, go ahead, like it's good. All right, the return 0 is like, no, it's not good. So that's what all of that is, and that's very confusing if you're new. But if you look at it and you try to like write some, if you print it out or you know, write some notes next to it, you'll start to understand, and you'll realize, oh, this is so easy. So this is a basic function, and this is telling it what to do. Okay, so now that we have our debounce, Remember we have our which floor. We're going to remember whether it's on or off. And I can set this equal to 0 or 1 or whatever, but you don't really need to. So let's go down to here. So if the button has been pressed and we double check to make sure it has been cleared out, the electricity has gone out through that push button into ground. And if the state of the button pressed is exactly equal to 0, that's what that double equals is. If it's exactly 0, then we're going to go ahead and use our function that we used to display, to do whatever, you know, is in here. So we're going to have display number 98. We're going to have display number 98765432210. So that's like an elevator coming down. It's counting down. One thing I would suggest is you could add additional delay to make it longer, because an elevator doesn't take just 1 second, unless it's a pretty fast elevator. It doesn't take 1 second for each floor. Some elevators are very slow. Depending on what you want to simulate, you can change the delay in here. And then you could take that out and you can say, you know, display that number, and then you can customize each floor's delay. I mean, you could do whatever you want. So it's, you know, taking longer and longer, it's slowing down as it reaches the bottom floor, whatever you want to do. All right, so now after I go from 9 to 0, so 9th floor down to 0, so on the display, it'll display 98765432210. I can count which floor is going to equal 0. So we're going to say which floor is equal to 0. You can say which floor is equal to 7, 8, whatever you want. I said 0 because, you know, I'm saying 0 right here. So it just makes it easier for me to remember. So I'm saying, okay, it is on the 0 floor. And then down here, and then I say, all right, now the button pressed is going to equal to 1. So yeah, it has been pressed. It's already been pressed before. That's what I'm telling the chip, so it can remember that, yes, the button has been pushed before already. And then here's my other if statement. So it says, otherwise, if the button was pressed is exactly equal to 1. You know, if it's debounced. And so we're going inside of this, we're inside of this debounce still. See that? See that curly brace here and the curly brace down here? Look, the if debounce includes this condition and this condition. You got to make sure that you understand this. You might need to take a few looks at this. So this else if statement is inside of this debounce. They're both these are both inside. So it's checking whether it's this or whether it's that. And if it's this, it does all that. And if it's this, it does all that. Okay, I hope you're starting to understand this. So then if the button press state is exactly equal to 1, so if it's already been pushed, we're just going to take it the opposite way. We're going to say go from floor 0 to floor 9. We only go up to floor 9 because it's a single digit display and you can only count up to 9. So you can get other 7-segment displays that have other digits, but I just want to keep it as simple as possible because I want people to understand this. All right, so then we go back up to 9 and we say which floor is equal to 1. It's not 1, but I'm just saying, yeah, this is the other state. It's at the top floor. 1 for me represents, you know, that's the top floor. You know, I'm saying yes and no, on and off. So which floor is equal to 1 instead of 0? In the button pressed state, I reset it back to 0. So if I pushed it again, it would say, hey, it's debounced. Hey, the button pressed is 0. Okay, let's go through here. And let's do this again. And then it'll, if I push it again, it'll say, hey, it's debounced. Hey, the button pressed is 1. Okay, do this again. Do you see? That's all. That's all it is. Okay, so you got to make sure you reset these, you know, these states, these values, so that the chip knows what to do. Now, the last part of this code that you need to know. So if you go to which floor, so if, the reason why I had to make these is because during the live stream, I noticed that it wasn't saving the state, like I said. It wasn't, so it went down to 0 and then it would just turn off. It would do the countdown and turn off, and then the other way it would count up and turn off, and I was like, no, I want it to keep displaying 0 and keep displaying 9. So that's why I made the which floor variable, which saves the state of whether it's at the top or the bottom. So I said if, so after all of this, so after it's done all of that, right? If it's checked for, if it's debounce, button pressed or not, it does all that, it'll check for this. It'll say, hey, if which floor is exactly equal to 0, which is what happens when it goes down to the 0 floor, display number 0. So it'll keep displaying number 0. If which floor is exactly equal to 1, remember we set the 1 for when it goes all the way up to the 9. You can change this to a 9 and then change that to a 9. That's the same thing. It doesn't matter. This is just easy for me, 0 and 1, you know. So when it gets to the top, we have a 1 for which floor, and if that's exactly equal to 1, then display the number 9 continually. Okay? And then if you push the button, it's gonna do it all over again. It's gonna go back the other way. And it works. I noticed that the code is not perfect and neither is yours, and who cares? You're not selling anything with it, so it doesn't have to be perfect. Nobody's life is on the line. You're gonna be fine. And this is how you close out the program, and that is it. So if we take a look at it, it's about minus the white spaces, which are these blank spaces, maybe like 88, 89 lines of code. Maybe a little bit less, a little over 80 lines of code. And that's not bad. Anything under 100 is a really small program. And if you look at it over and over and over again, you'll start to understand it, I promise. It just takes time. So here you can see the button in action with the 7-segment display and my microcontroller. The code is in the microcontroller. It is sending out electricity to the push button, and it is listening to see if a voltage is dropped on pin PC0, which is connected to the button. When it does, depending on the previous button press state, it will either count up or down through our 0 through 9 number series. And this is how we simulate our imaginary elevator moving through each floor. Now you're ready to put everything in the box and attach it to that elevator and get the hell out of here. What do you say? You ready?
Jeff, I did it. I got it working. I'm finally gonna get out of here. All right. Well, let's see. It says I'm on sub-level B20.
Maybe you should come back inside.
What? Are you kidding me? Jeff, look, I know we've been through a lot the last year and a half together, but I need to get out of here. I need to go and meet new people and get some fresh air, you know, kind of like a vacation. I need to get out of here. I don't even know where I am. It's been nice knowing you. I'll send someone down to, you know, service you and whatnot. All right, let's see. What do we want? On ground floor. There it is. Bye-bye, Jeff. Don't miss me.
Son of a bitch!
Next time, bring me a snack.